All right, let's dissect this paper on RAGProbe. It's tackling a pretty crucial issue in the world of retrieval augmented generation, RAG, automated evaluation. The authors claim RAGProbe significantly improves upon existing methods. What's the core problem RAGProbe is designed to solve, and why is it so important?
The core problem is the largely manual and time-consuming nature of evaluating RAG pipelines. Currently, testing often involves a trial and error approach, which is inefficient and doesn't guarantee comprehensive coverage. This is critical because RAG systems are becoming increasingly prevalent, and their reliability is paramount, especially in high-stakes applications. Automated evaluation allows for continuous monitoring and quicker identification of weaknesses.
So manual evaluation is the bottleneck. What makes automating this process so challenging? What are some of the hurdles the authors highlight?
The challenges stem from the inherent complexities of natural language. RAG pipelines can fail due to various reasons: context misunderstanding, incorrect formatting, insufficient specificity, or missing content. Existing methods often focus on improving metrics or enhancing individual pipeline components, but they lack a systematic approach to generating diverse test cases that cover these failure modes.
That makes sense. How does RAGProbe address these challenges? What's its novel approach?
RAGProbe introduces the concept of evaluation scenarios. These scenarios define a structured way to generate question-answer pairs designed to expose specific weaknesses in RAG pipelines. Each scenario specifies document sampling, chunking, prompt engineering strategies, and relevant evaluation metrics. This allows for targeted testing of different aspects of the pipeline.
So it's not just about generating random questions, it's about crafting questions to specifically target potential failure points. Can you elaborate on these evaluation scenarios?
Absolutely. They cover a range of complexities. Simple scenarios involve retrieving numbers or dates from single documents. More challenging scenarios involve combining multiple questions, requiring answers from multiple documents, or posing questions unanswerable from the given corpus. This variety is key to thorough testing.
And how does RAGProbe actually generate these question-answer pairs? What's the underlying mechanism?
RAGProbe uses LLMs, large language models, like GPT-4 and GPT-3.5 Turbo, to generate the question-answer pairs based on the defined evaluation scenarios. It takes a document corpus as input and applies the scenario specifications to generate relevant questions and their corresponding answers.
Interesting. So it's essentially using an LLM to test other LLMs. How did the authors validate RAGProbe's effectiveness?
They evaluated RAGProbe against 5 open-source RAG pipelines using 3 datasets: Cosper, Academic, Google NQ, and MS Marco, both open domain. They measured the failure rate of each pipeline across the different scenarios.
And what were the key findings? Did RAGProbe reveal significant weaknesses in the tested pipelines?
Yes, significantly. The highest failure rates were observed in scenarios involving multiple questions, especially those spanning multiple documents, 91% failure rate. This highlights a critical area for improvement in RAG pipeline development. Overall, RAGProbe revealed a much higher failure rate than the state-of-the-art approach, RAGUS, increasing the failure rate by 51% on average per dataset.
That's a substantial improvement. What about the impact of the different datasets, academic versus open domain? Did that influence the results?
Interestingly, while the academic dataset, Casper, showed a 60% failure rate, the open domain datasets, Google NQ and MS Marco, showed similar high failure rates, 53% and 62% respectively. This suggests that the challenges aren't solely domain-specific. Rather, they're inherent to the complexities of handling diverse question types.
So the problem isn't just limited to one type of data. What are the key takeaways for researchers and developers based on this work?
For researchers, RAGProbe provides a solid framework for creating more comprehensive and targeted evaluation scenarios. They can expand upon the existing scenarios and incorporate additional evaluation metrics. For developers, RAGProbe offers a practical tool for continuous monitoring of RAG pipeline health, easily integrated into CI/CD pipelines. The authors mentioned some threats to validity. Can you briefly touch upon those?
Yes, they acknowledge limitations. The study primarily used GPT models from OpenAI, limiting generalizability. Also, they didn't explore all possible evaluation metrics or prompting techniques. These are areas for future work.
What about the comparison with other existing tools for evaluating RAG pipelines? How does RAGProbe stand out?
The authors compared RAGProbe to RAGUS, A state-of-the-art approach. RAGProbe not only revealed a higher failure rate, but also generated a higher percentage of valid question-answer pairs, indicating better data quality for evaluation. Other tools lacked the comprehensive, scenario-based approach of RAGProbe. So, RAGProbe offers a more systematic and effective way to generate test cases, leading to more robust evaluation. What are some of the practical implications of this work for improving RAG pipelines?
The identified failure points, particularly those related to handling multiple questions, provide clear guidance for developers on where to focus their efforts. The authors offer recommendations for addressing these issues, such as upgrading embedding models, improving LLMs, and refining prompt engineering techniques.
This has been a very insightful discussion on RAGProbe and its implications for improving the reliability of RAG systems. Thank you.